go ahead and get started. So I'm going to go ahead and share. I think I can make a spotlight here. I'm trying this out. Let's see, maybe I have to do this. There we go. I think once I pull my screen up, you should be able to see. So let's go ahead and get started. So if you just watched last class or whenever you watch last class, we just finished talking about proportions. So we have a couple more things that I want to fill in about proportions. And so you can see written in lovely lettering over here is the word proportions. So we're going to keep talking proportions. So remember, proportions are just two ratios that are equal to each other. And if you remember in our last call, we decided, or I shared with you that 6 out of 11 students like pumpkin pie. So we're going to keep going with that, and let me write write a proportion that's equal to that. So if I extend that ratio out to all of PEP, and let's say that there's 231 students at PEP, okay, that would mean that I'm going to use cross multiplication to solve this. That would mean that 126 students like pumpkin pie out of 231. Okay, so I just want to set that up so we can kind of use that as an example. And the first property of proportions I want to talk to you about is what we actually talked about last class, which is cross product. So if a proportion is true, then the crossed product should be correct. So what I mean by cross products is we're going to multiply the extremes together, which would be 6 times 231. And that should be equal to the means multiplied together, which is 11 times 126. Okay, so then if you do the multiplication on that, you should end up with, both of them equal 1,386. So they work out, checks out, that means that our cross products work and we should be good to go. So again, we're talking about properties of proportions, so I just want to let you know that that property is true. Actually, you know what, guys? I'm going to give us a much easier one to work with. So let's just kind of make one up here. I'm going to make the proportion 2 to 3 equals, how easy should we make it on ourselves? How about 6 to 9? Right? So that's another proportion that's true. That doesn't even look like a 9. Let's talk about that one because it's going to make our lives a lot easier. So we'll talk about this proportion. Okay, so the other properties I just want to share with you for 6.2 are the ones listed right here. So additional properties of proportions. So the second property that we're going to talk about, the first new one today, is called the reciprocal property. So think about what a reciprocal is. Reciprocal, if you have 1/3, the reciprocal is 3/1. It's flipping the numerator and denominator. So the reciprocal property says if you have A over B equals C over D, then if you flip the numerator and denominator, then B over A should equal D over C. Okay, so in our example up here, we had, 2 to 3 equals 6 to 9, which I think we can all agree is a proportion, right? That also means that 3 to 2 equals 9 to 6. And I think everybody can see, oh, okay, yep, that makes sense. So this is the reciprocal property that we can do that, okay? Property number 3 is what I like to call the means property. So the means, remember, are the numbers here and here. And so if property number 3 says if you interchange the means of a proportion, then you form another true proportion. So if you have A over B equals C over D, then A over C equals B over D. So this one's kind of interesting. The third one here is, again, remember our original is 2 to 3 equals 6 to 9, right? So if we can interchange our means, and that means that 2 to 6 has to equal 3 to 9. So I interchanged the means here. I didn't multiply, I just changed them back and forth, right? Sorry, I'm going to move my mic. Sorry about that. They're not the same ratios, right? This is 2/3 equals 2/3, and this is 1/3 equals 1/3, but they are still equal proportions. So these, again, are not properties about ratios, they're properties about proportions being true. Okay, and then the last one, which I don't even have a great name to it, I called it magic in class, but I don't even know if that's good, has to do, it's kind of a weird, interesting thing that actually works. So again, your proportion is A over B equals C over D. Okay, if you take the denominator and you add it to the numerator and then keep everything else the same, then your proportion stays the same. So the property says if A over B equals C over D, then A plus B over B equals C plus D over D. So I think this is the most interesting one to watch. So again, 2/3 equals 6 out of 9. Okay, so what we're going to do if we try to use the fourth property of proportions is we're going to add the denominator to the numerator. So it's going to be 2 plus 3 over 3 equals 6 plus 9 over 9. Okay, so we do some simplifying. We get 5 over 3 equals 15 over 9. And look at that. I mean, again, it's not the same ratio, but it's still an equal proportion. So that's the fourth property of proportions. So what you'll do in your homework is just practice some of those. You'll try, it might tell you to use one of the properties. You might have to kind of mix and match that, but it's kind of interesting, right? And then the second part that we went over in class is let's actually use a proportion to solve. So this figure right here, okay, is all nice and labeled. I don't even have to draw it, so that's easy. And they're telling us that JL over LH equals JK over KG. So if I look at this picture, J to L is this line here. That divided by this little line is equal to JK right here divided by this line here. So it's a proportion. They tell us the proportion is true. What I always like to do to solve a proportion is just to try to fill in what I know from the diagram and then use that to solve. So I know, and I'm actually going to start over here. So I'm going to start on the right-hand side. So J to K, if I look at my diagram, I know that's 15, all right? And I know that from K to G, that's 5. All right, I got a ratio already. That's awesome. Okay, then on the other side, I want to know from J to L divided by L to H, which is 2. All right, so sorry, I should have looked at what I was trying to find. I'm trying to find how long is JH over here, which is X, and JL, which is some distance that's shorter than that. Okay, so my geometry students today actually did a shortcut because I did an even longer way. They said, let's just leave JL as JL. And I was like, okay, so what I have here is a proportion, right? And I can multiply, and I can say 2 times 15, those are my means, equals 5 times JL. All right, then I divide both sides by 5, and I find out that JL equals 6. Cool. JL equals 6 up here, right? So if I wanted to find what JL is 6. And then I also need to figure out what JH is. Well, JH is the distance from J to L and L to H, which would be 8. So I add 6 plus 2 together to get 8. Okay. And then just if you want to practice a little bit more, let me erase all this on here. Again, there's longer ways than that because I did a longer way and the book did an even longer way, but that's kind of the most elegant way. Another example, if you want to try another thing, is, well, we also know that KL, which is right here, KL is to GH, so this KL is to GH, as JK is to KG. So that's another proportion that we know. So again, what I like to do is just take the proportion and plug in what I know. So KL, right? KL I know is 12. GH is what I'm trying to find. I don't know that, GH, right? As to JK, which is right here, which is 15, to KG, which is 5, and voila, another proportion, right? So cross multiply, and you get 15 times GH equals 12 times 5. Divide both sides by 15. And yeah, I think I did that right. You should end up with, nope, hold on, I did something wrong. 12 to that is 15 to 5. Oh, Sorry, I was not reading my problem right. Look at, I did a little, oops, because look at here. This should be G to J. Because what I noticed right away is my numbers aren't going to be right. Whatever G to H is has to be bigger than 12, and so that's not what's going to work out. So back up. My magic eraser on here. Sorry for the clicking. There we go. So here was my mistake. Look, I just assumed it was the same proportion, but it's actually J to G, not K to G like the one above. So the distance from J to G is actually not 5, it's 20. That should help us out a little bit, right? All right, so then if I cross multiply, I'm going to get 15 times GH equals 20 times 12. And then divide both sides by 15, and we end up with GH equals 16. Much better, right? We know that GH has to be bigger than 12. There's no way that GH could have been, what was it going to be, 5 or 4, something like that. That wouldn't have worked. So, all right, so that's 6.2 in a nutshell. Again, you're going to work on some properties in the beginning and then work on some proportions with diagrams at the end. So just good to keep practicing, and always ask any questions if you have them. Take care.